CHNEP.org. With that, we're going to move on to the next presentation. Thank you very much. Next slide. Also with FWC, Dave, are you on the line?
Yes, I am.
Great. Go ahead.
Okay. Thank you, Jennifer. Great to join you guys for this summit again. I just want to talk to you a little bit about our harbor, Charlotte Harbor, an exceptional estuary that needs our close attention. You can, next slide, please. Yeah, we've got, as Nate mentioned, we have quite a few different estuaries that are that have the Fisheries Independent Monitoring Program. And in Charlotte Harbor, we've been monitoring fish populations since 1989. I joined the program as a fisheries biologist back in 1992, and my co-author, Courtney, she joined the program in 2015 as a fisheries scientist and as our project lead. And yeah, I'll take next slide, please. Our program directives are, this is just some of our directives. The main ones would be to track abundance of fish in Florida's estuaries, determine the effects of regulations, pinpoint essential fish habitat, and investigate effects of natural and man-made disturbances. Next. And our research in Charlotte Harbor has shown that this is an outstanding estuary for sport fishes. We have a lot of published manuscripts that document this. Exceptional habitat for adult snook, spotted sea trout, sheep's head, and many other sport fishes. In addition, it's exceptional nursery habitat and juvenile habitat for these sport fishes. Not just snook, spotted sea trout, and sheep's head, but also for fish that use Charlotte Harbor in their juvenile stage, like tarpon, redfish, gray snapper, and gag. And as was mentioned earlier from Rachel's talk, it's an excellent nursery habitat for endangered small-tooth sawfish. In addition to that, we have high abundance of forage fish, and we have a great diversity of fishes. And in this talk, I want to go over a little bit about the diversity of fishes, talk to you a little bit about our sport fish, go over a brief life history of several iconic species, and fill you in on some challenges that Charlotte Harbor is facing with algae blooms that started abruptly in 2012. And just kind of, this talk isn't real heavy with graphs. It's more of like a virtual field trip. So if you could show me the next slide. So this Charlotte Harbor has diverse habitats, and this is reflected in its diversity of fishes. Our program's collected over 250 different species of fish, which is really amazing and quite incredible to see out in the field. And I'll take the next slide. I'm just going to show you a few interesting ones. I could go all day going over all these species, but just a few interesting ones. Here's hogfish. That's a juvenile that they grow up in the seagrass beds and the sounds and near the barrier islands, and eventually move out in the Gulf of Mexico as adults. To the right of that is the cubbyou. That's in the drum family, similar to a red drum, but only gets about 10 inches. That's a really neat looking fish. Next slide. Balloonfish, just to show you they're more than just a curio at the shell factory. They really swim out there, and they're really neat fish. This is the Atlantic spadefish. This is our the estuarine angelfish. Next slide. This is the line sole. This is a common flatfish that's found all throughout Charlotte Harbor, and that's about the average size of what we catch. Next slide. And here's a really interesting fish, the polka dot batfish, a bottom dweller in Charlotte Harbor, and quite common. Next slide. In addition to having great diversity, Charlotte Harbor has an abundance of forage fish, and these fish really drive the system. Next slide. They provide an incredible prey base for some of our most popular sport fish. Next slide. But in addition to the fish that people are more familiar with catching, there's a variety of other fish, sport fish that occur in Charlotte Harbor. One of those species is gag. These fish grow up in the seagrass beds as juveniles, and then as they grow larger, they will eventually move offshore and live their life in the Gulf of Mexico. Next slide. The same goes for the Goliath grouper and the red grouper, which grow up in the estuary as juveniles. Next slide. We also catch juvenile and adult black drum in Charlotte Harbor, which is a really neat fish. Next slide. And we catch juvenile permit in Charlotte Harbor. Permit grow up in Charlotte Harbor and then eventually leave at about this size in the picture, is about the size that they'll end up leaving and going out and living in the natural and artificial reefs in the Gulf of Mexico. And as of the last 6 or 7 years, we're catching more bonefish than we have in the past. So that's really interesting too. Next slide. Some of our less common species but important predators in Charlotte Harbor are the small-teeth sawfish, juvenile bull shark, spotted eagle ray, long-nosed gar. Next slide. I just want to take a few minutes to highlight 3 of our most iconic sport fish, tarpon, snook, and red drum. Just fill you in a little bit about their life histories and how they use the estuary. Next slide. Red drum, they live up to 40 years. It takes about 4 years to reach maturity, approximately 3 feet long. Juveniles grow up in the estuary. Adults live primarily in the Gulf of Mexico. In fall, they spawn in the Gulf of Mexico about 100 miles offshore, and their larvae transports to the estuary. There's a picture there of a 50-day-old juvenile redfish, and up in the top right corner is a larger juvenile redfish. That's about the size that they transition, leave the estuary, and go to the Gulf of Mexico and live out the rest of their lives. Next slide. Tarpon live in excess of 50 years. It takes about 8 to 10 years to reach maturity, approximately about 5 feet long. Juveniles grow up in the estuary. Smaller juveniles grow up in salt marsh ponds, creeks, rivers. Larger juveniles move into the bay. Adults live primarily in the Gulf of Mexico and the Atlantic Ocean. And in spring, the adults congregate in Gulf passes, beaches, and in the estuary to feed before going out about 100 miles offshore to spawn. Again, the larvae transport to the estuary. Next slide, please. And snook live about 20 years old. Only takes them about 2 years to reach maturity, approximately 1.5 feet long. Juveniles also live in salt marsh ponds and creeks. Adults live in the estuaries and the rivers, and they spawn in the passes from May through September. Next slide. So these fish are heavily tied to the estuary. Of course, snook live their whole lives there up to 20 years. Tarpon up to 10 years until about 5 foot, and then they still come back seasonally. And red drum are in the estuary for 3 to 4 years. So these fish are clearly important species within our estuary, and they're important for a number of reasons. They provide balance in the ecosystem. Obviously, if you have healthy populations of large predators, you usually have a healthy system. And they're important to anglers, and they provide recreational opportunities. And they're also a critical component to our economy. Next slide. So we have several focus points that our agency uses to promote healthy fish populations. Typically, this number 1 point is what I've been mostly involved with during my time here at FWC, and that's the identification of critical habitats and conservation, and also, when necessary, restoration of those habitats. So the idea is that if we have an abundance of good habitat, we're going to have an abundance of fish. Also, our agency sets high benchmarks for fisheries regulations that promote healthy populations. One example of that is snook conservation with a 40% spawning potential ratio, which is something that was put in place with the help of stakeholders, which helps protect the snook population. We also enact emergency closures due to disturbances such as cold kill and red tide. Go back one sec. And our third point is about water quality, which without good water quality, points 1 and 2 don't really matter. So it's important that we provide support for good water quality to help assure the health of our estuaries and our fish populations. Point 3 has become more of a focus for us as we have FWC FIM crews that have monitored and witnessed the rapid decline of fisheries in one of Florida's most treasured estuaries, the Indian River Lagoon. Right around the same time as the Indian River Lagoon was experiencing massive algae blooms in 2011, we also started to notice a large-scale change in the types and amounts of macroalgae in Charlotte Harbor. Next slide. So historically, green filamentous algae was rarely ever observed in Charlotte Harbor, but starting in 2012, we had 4 major outbreaks that occurred throughout the harbor. Next slide, please. So the first outbreaks in 2012 and 2015 were mainly centered around the northeastern harbor, which is the West Wall, Hog Island, and the mouth of the Mayaca River. And then in 2009, we had the east branch of Coral Creek, which is near Placida. And then now in 2019 and 20, our largest bloom stretches from Harbor Heights all the way down to the Matlacha Bridge on the eastern side of the harbor. Next slide. And just to give you an idea of how rare green filamentous algae was, basically for 20 years I rarely ever saw it, or we rarely ever saw it. And in here in this data, this graph will show you that from 1996 to 2011, this is our records of a bycatch whenever we pull a seine or a trawl, we will record the bycatch, whether it's algae or shells or leaf litter. And this is a record of that bycatch. And so you can see that in 2012 and 2015, those 2 events come out very strongly. And this same pattern was seen by the DEP aquatic preserve staff with their seagrass monitoring. Next slide. And then this is a picture of the 2019 East Branch Coral Creek algae bloom. And this covered almost the entire section of that branch. Next slide. And currently we're dealing with the Eastern Harbor. This is the longest and largest event to date, and this has occurred throughout 2019 and is still going through 2020. This outbreak covers almost the entire eastern shoreline of Charlotte Harbor, from backwaters to deep open habitats, up to 3 meters, and includes the mouth of the Peace River. Next slide. So a high volume of macroalgae indicates a high amount of nutrients within a system, and it's a clear warning sign that trouble could be around the corner. Next slide. So nutrient pollution is a process where too many nutrients, mainly nitrogen and phosphorus, enter bodies of water, and then they act as fertilizers, causing excessive growth of algae. Excessive amounts of algae block out sunlight, which causes large-scale die-offs of seagrasses and can cause complete shifts in organisms. And usually it's to less desirable species, so you end up with more catfish and less sport fish. Next slide. Other areas of Florida have had or are having nutrient issues. Parts of Tampa Bay crashed in the 1960s because of poor management of sewage treatment facilities. However, that community came together. They did respond, and they enacted solutions, and their estuary is back on track 20 to 25 years later. The Indian River Lagoon on the east coast of Florida has experienced constant algae blooms since 2011. That's microalgae blooms. They've always had macroalgae for as long as we've monitored that area. This has affected the entire ecosystem, these microalgae blooms. with devastating seagrass losses and large shifts in fish populations. And then a little closer to home, we all know the troubles that the Caloosahatchee River is facing. Next slide. And in the Indian River, combination of the freeze and the cold kill caused the snook population to crash, and it's not recovered. Where it has recovered in Tampa Bay and in Charlotte Harbor within 2 years. Next slide. So could this ever happen to Charlotte Harbor? Or this could never happen in Charlotte Harbor, right? Next slide. So this has kind of been my thought, was that Charlotte Harbor was kind of untouchable, and we have a lot of shorelines preserved, and we have seagrass beds historically that have been in good shape. So these visual buffers can give us a false sense of security about the health of the harbor. Next slide. So if we look just right behind the mangrove fringe, how does the watershed look? We've got a lot of really large developments that are already cut and that are just being filled in one home at a time. And these all drain directly into the harbor. Next slide. So we need to know more about these urban watersheds and how they function and how they impact Charlotte Harbor. Next slide. And I think the good news is that there's been a growing awareness about the algae issues in Charlotte Harbor, and many of the agencies were coming together with citizens, and hopefully we can start to identify where our major nutrient sources are and then take action to make the necessary changes to avoid a crisis in the future. Next slide. Next slide. And thank you very much.
Great, thank you so much, Dave. That was a great presentation, and we're going to move into Q&A. Unfortunately, we've had a little issue with Minty. We've been trying to work on it in the background, but what we're going to need to do alternatively, and we only actually have about 2 minutes for Q&A anyhow, is just enter your questions in the comment chat, in the chat directly to everyone, and I'll go ahead and read those aloud for Dave to answer. Or likewise, Dave, you could read them aloud and answer them as they come into the chat.
Okay.
All right, the first question is, can you speak to how much is attributable to LORS, the Lake Okeechobee Regulation Schedule?
Oh, okay. I don't believe that that it has to do with just because of the currents of the Caloosahatchee. So I don't believe that it's attributable at all. But
so the flow rates for sawfish habitat that sometimes push it out of their preferred range, do you feel that those have any impact?
You're talking about the high flows in the Caloosahatchee. Does it have an impact on the upper harbor?
Yeah, with any species, not necessarily just the species you spoke on.
Yeah, no, I think what's driving Charlotte Harbor the most is probably flows from the, as far as freshwater goes, is from the Peace and the Maca rivers. So that's, you know, that's really what's driving probably movements to and from away from fresh water.
Okay, great. And the next question is, does the green filamentous algae affect the fish by changing the habitats or anything more direct?
Well, in the case of the Coral Creek, that particular episode did block out a lot of light for a period of time, and it seemed to transition from a rupia seagrass area to a mud-dominated system. So in that situation, it did affect it greatly. So we had shifts from juvenile snook and trout, and lots of Lucania parva, which is the rainwater killifish. And now that area is dominated by Mahara and clown gobies. So that was a big shift there. In other places where the seagrass isn't lost, the shifts aren't so noticeable, but we are noticing shifts where the algae is out into the deep water. Normally the bottom is sand and there's not a lot of habitat there, but the algae is actually creating habitat for some fishes, and we're seeing certain fishes that we don't normally see out into deep water. So it is shifting, and it actually can make things look like, wow, we're getting more fish, but in the same sense, it's not necessarily a good thing.
Well, thank you. Unfortunately, that's all we have time for today. I know there were some additional questions. I encourage those of you who did have those questions to reach out to Dave directly. His contact information is in the proceedings online. With that, I'm going to turn it over to our next FWC presenter, Corey Anderson.